Hello everybody, this is a video about the area of rectangles and parallelograms. I am your host, Mr. Shirley, dropping a math bomb up in here. Please make a note as you go through this video, as usual. Please title and date it, and as you might expect from the title, we'll just be looking at some ways of finding the area of rectangles and parallelograms. Okay, so again, please write this down. You'll be writing down most of the note for today, but there's really not that much to write. So the area of a rectangle is just simply length times width. Okay, you should hopefully be familiar with this from past years. And remember as well, a square is simply just a type of rectangle. So a square, you can find the area of a square in exactly the same way. Still length times width. Except in a square, they happen to be exactly the same number. Okay, so I'd like you to pause the video and try out the example right here. Okay, on we go. So we have a rectangle. I guess I didn't add any little right angle signs or anything like that, but it's a rectangle. And so the area equals length times width, which equals 3 times 8, which hopefully you got as 24 centimeters squared. So remember, you need a unit. And whenever you're dealing with area, you have a squared above it, okay, because we're multiplying our units together. You should end up have a square unit. There's more explanation involved in there, but I'll leave it at that. And it, as with perimeter, it doesn't matter which dimension here you treat as the length and which is the width. Because you're multiplying them together, you will get the same answer no matter what you do. So feel free to switch the 3 and the 8 and you'll get the same thing. Alrighty, next we have the area of a parallelogram, okay, and just to recap quickly, a parallelogram, the sides, it's almost like a tilted rectangle, okay, so opposite sides are equal length, alright, and they should be parallel with each other, hence the name parallelogram. But what we need from this, okay, is that we need the height of it. Okay, so that's inside the parallelogram, although sometimes they'll draw the arrow outside, but it's the same distance measurement. And so we need the base and the height. Okay, and it's important to note that if the base is the bottom here, the height is most definitely not either of these sides. Okay, the height is right up at right angles from the base. Okay, so it goes straight up the middle there. Okay, and the area equals the base times the height. Okay, it's a very, very similar formula to a rectangle, but again, please make sure you're not multiplying the base times one of the sides. Okay, for the area, we don't actually care what these side lengths are. For perimeter, we would need to know, but for area, it doesn't matter. All right, so pause the video for a moment and try out this question here. It's not too tricky. All right, I'll assume you tried that out. Now, the dimension is up on the top here, but if you remember, since the top and bottom are the same length, rather, the base is going to be 6 meters as well. Okay, so our area is base times height, which is 6 times 4, and 24 meters, and it looks like I forgot Mr. Shirley, for shame. Okay, forgot our little number 2 that goes up there for 24 meters squared. Now, I just need to quickly note before we end the video here that the base of a shape does not necessarily have to be on the bottom. Okay, it's an important distinction. The base is going to be whatever is at right angles to the height. Okay, so if I took this entire shape and twisted it 90 degrees so it was kind of up and down, and the 4 meters was going side to side, the 6 meters would still be the base. Okay, even though we flipped it on its side. Okay, so it's an important distinction to make there, that the base does not have to be the bottom. All right, so please try out the work that I've posted with this video, and please ask me any questions that you might have in all of the usual ways. Thank you very much for watching, and have a super day.